So while Adrian is taking his device off, we should start with the next presenter, Mr. Zoltan Balazs. He told me that I shouldn't speak a lot because he will. So I just would like to mention the title of his presentation, which is Zombie Browsers Spiced with Rootkit Extensions, whatever it means. So thank you, and please.
My name is Zoltan Balazs, and I work as an IT security consultant for Deloitte Hungary. I'm also a proud member of the Goulash team. We are in the Cyber Olympics finals. What you have to know about me is that I love hacking, I love zombie movies, I love lolcats. So that's why I had the idea to create these zombie browsers. I hope you will enjoy my presentation. So we will first quickly go through of the history of malicious extensions. I will talk about the advantages and disadvantages of these malicious extensions. I will talk about rootkits, and last but not least, I will show you the malicious extensions I have created. Most of you remember how an average Internet Explorer 6 looked like in 2004. I bet all of you were crazy of those crappy extensions. Do you remember that irritating purple monkey dancing in the corner of your browser? It is one of the first malicious extensions which spied on browsers using Hacktivity. Exponential diagrams are a must-have in IT security presentations, so here you go. I have downloaded and analyzed the publicly available Firefox malicious extensions from Mozilla, and it looks like that more than 90% were just created to just spamming Facebook. In the beginning of the Firefox history, it took 6 years to create 5 malicious extensions. The next year, another 5 appeared, and this year, these malicious extensions are just skyrocketing. 48 has been created so far. But I do believe that these malicious extensions can be much more dangerous than just spamming your Facebook wall. If you are a Facebook user, hands up, please. So what I'm going to say now is nothing new for you. You see interesting posts on Facebook like the funniest sex section, save the little cat, eat a Cheesecake Factory for free. But if you want to look at the content, there will be a tricky step which you don't know what will it cause on your computer. And sometimes these extensions are multi-platform, so they can run on Internet Explorer, Chrome, or Firefox. My extension works the same way as zombie computer works, which means that the infected browsers are polling their master server for new commands, and if there is a new command, it will execute it. My extension is able to steal cookies, passwords, upload and download files, even execute binary ones, and much more. Here, I'm introducing you the LL company we will hack, and this company has a lot of defensive solutions from firewall to application whitelisting. And I'm also introducing you the brave hacker who wants to hack this LL company. And after he managed to infect one of the user's browser, this browser will poll the web server for new commands. But as you might know, Firefox is even supported on OS X, Linux, and even on Android. But you must say that that's okay, but for example, Chrome or Safari is a very secure browser, so you cannot do that on Chrome or Safari. And I said, challenge accepted. I will create Chrome and Safari extensions as well. So there you go. These are the supported platforms right now. But enough of chitter chat. I will show you the Safari extension. How does it work? So first I'm opening my Safari browser here. And unfortunately there is no network connectivity, but it doesn't matter. I uninstall my extension, and as you can see, this is the latest Safari, at least in my operating system. And I'm also switching right now to the botnet control server. A couple of seconds. And here you can see this is the control panel where I can send new commands to the supported browsers. As I have mentioned, you can see Firefox, Chrome, and Safari here, and on a lot of different operating systems like Windows 7, OS X, Android, Linux, and even Windows 8 is supported. In the background, I have already started social engineering toolkit plugin I just wrote for this demo, and this plugin will emulate a fake YouTube website. So I'm going back to the victim side. Come on. And let's say that we have convinced the user to click on a link on YouTube where he wants to check a video. It should be faster. But there you can see the fake YouTube website, and if the user wants to look at the content, he notices this error message here, and he tries to download a new Adobe Flash Player plugin. So he clicks on this download button. Usually it's much more faster. And he installs the new extension into Safari. Let me check that it's correctly installed. Yes, as you can see, it's there. And we are switching back to the attacker side. And if I click refresh here, just a minute. There should be, there it is. So first I'm clicking on the demo button, and I haven't mentioned, but when you are in the browser, this means that you can execute any JavaScript commands in the currently visited website. So I will just click on this button and send custom JavaScript commands to the browser. So I click here, and on the other pane, there you go. We can execute any JavaScript commands from the browser. But let's go back to the slides. You might ask, how can I install these extensions into the browsers? There are the traditional ways like physical access, the social engineering I just showed you, or if I have remote code execution, then I can install my extensions into the browsers. On the right side, you can see screenshots for my meterpreter auto-run scripts I just created. So if you have a meterpreter shell, then you can install these extensions into Firefox or Chrome. And there are also many ways to hide these extensions from the user. The first way is if I have remote code execution, then I can basically install my extension into an already existing one. And as you can see in the pictures, this only means one additional line in the configuration file and one additional file in the extensions directory. And if I have remote code execution, then I can set the visible flag in the Firefox configuration to false, which means that when you check this extension in the extension listing page, you won't find it there. I don't know what kind of purpose they thought when they created this flag, but that's okay. And what's even more scary is the third way. If the extension is installed via traditional ways, then it can hide itself from listing. And I have already seen this code in the wild in real malicious Firefox extensions. And here's a little quiz for you. The first person who answers my question will receive this hacker beer, but not right now, but in the evening. And the question is, which company developed the first Netscape plugin? No, not Microsoft. The stars indicates the length of the company name. No, not Apple. Yes, that's right. Adobe is the right answer. And what's really funny is the fact that even after 17 years of experience in plugin developments, they are still making some mistakes, we might say. All right, but you might ask, what are the risks of a zombie browser? Will it eat your brain while you are asleep? Well, no. But what I'm going to say now is really important, so you better listen to me. Because these extensions use traditional HTTP protocol, this means that it can go through firewalls and proxies. And also, if you have a locally installed software firewall, it won't notice a thing because the browser is communicating with the internet. And the same applies to application whitelisting. There are also companies where they don't allow users to download executable files via some web filtering solutions. Well, don't feel secure because these extensions are just simple JavaScript files, so they can go through these web filtering as well. These extensions are cross-platform, which means that they can run on any operating systems where the browser is supported, whether it's OS X, Linux, Windows, Android. These extensions are at least as evil as cross-domain universal cross-site scripting on every website you visit. And you have to also know that every secret in the browser is available to the browser, like passwords, credit card numbers. And it doesn't matter how it was typed into the browser or whether the site uses SSL or not, the browser extensions can read this stuff from the browser. And you might also ask that that's cool, but what are the advantages against Meterpreter? Well, if you want to achieve some persistence in Meterpreter, then you have to upload exe or DLL files onto the victim machine, or you also have to write something into the registry, which might code by some antivirus solutions. But in the case of malicious extensions, none of them are necessary. And these malicious extensions are not detected by antivirus vendors. I have downloaded from the internet a publicly available malicious extensions, which is publicly available from January 2011, and even after almost 2 years, none of the antivirus vendors detect it. And I also have to say that behavioral-based detection won't protect you neither. But come on, how hard could it be? On this slide, you can see samples from these publicly available malicious extensions I have just downloaded, and which are not detected by antivirus vendors. For example, look at the last one. For var x in mothership, if mothership command equals eval mothership data. This is ridiculous. I really want to reach this message, the antivirus developers. Please try harder detecting these extensions. Because you know there is real money in this business, and the organized criminals will find this very soon. Just remember the exponential diagram I just showed you in the beginning of my slides. But let's go on, and I will show you my Firefox extensions, how they work. So here I'm opening the victim browser, and here you can see that my extension is installed into the Firefox, but if I click refresh, it quickly disappears. This is the rootkit mechanism I just told you, and it is just for the demonstrational purposes that you have seen it in the beginning. And first, let's just test whether the communication is working between these machines. By simply sending a custom JavaScript command to the website. Demo gods again. So, as you can see, I can also execute binary files from the browser. And let's try again this custom JavaScript command. All right, so it's working. We can execute any JavaScript, which means that we can change the content on the website, grab any form fields, and stuff like that. And because I just mentioned that we can change some content, then I'm going back to this part. And what I'm gonna show you right now is that I can change any content on any website with these extensions. I have chosen a popular Hungarian website for this demo, which is index.hu. And first, the attacker is checking the current currency rates on index. And there you can see, it's about 230. And then he changes the configuration for the infected web browser, that if the user is on the index site and there the extension sees this currency rate, change that for 4. So we are switching back to the victim side, and the victim looks his current currency rates because he bought a really expensive house, and he's shocked because the currency rates has been risen so big. And it was just for the demonstrational purposes that he has seen the original currency rates in the beginning. So, but there are also disadvantages of these malicious extensions against malicious native code. For example, it cannot be a real rootkit. So if an antivirus really wants to detect it, it will. There are both browser-based and platform-based limitations. And it also runs only in user space and only when the browser is open. But I don't think it's a real limitation because usually every secret is available to the user. And unfortunately, the extensions are not yet supported in Chrome when it's running on Android and iOS, and Safari does not support extensions on iOS yet. I hope they will. And on this picture, you can see the explanation for the next demo. I will just show you. So the infected browser is checking for new commands from the web server. And there is a new command which will instruct the victim browser to connect to an internal web server. And the internal web server will send back the response to the victim, and the victim browser will send back the response to the attacker. So we can basically tunnel or traffic through the victim browser, like a proxy. So here you will see some debug messages I wrote just for the demo. And here we first check whether the application is reachable for the victim browser. So we will just test the application. And here we will see the results which has been sent back from the victim. So we open it. And as we can see, it's just a simple web-based form. Nothing special here. But then, when we click on the next button, we will test the internal web server for SQL injection. And in a couple of seconds, when we receive the response, we might see that the application is vulnerable to SQL injection. So, as a good hacker, we start to write a new union select statement just to extract any data from the database, which is used by this web server. In this demo, I've just created some sample credit card numbers just to demonstrate the SQL injection, but it can be any data. It doesn't matter. And in these debug messages, you can see that the whole traffic went through the browser. You can use the Chrome rootkit functionality as well, which I will show you right now. So there you can see that my extension is already installed into Chrome. And in the Chrome configuration, there is a custom style sheet file where you can define the ID of the Chrome extension. And if you set the CSS style to not to display it, I just save it. And there you can see it's not there. It disappeared. And the next demo I will show you is the idea and implementation of my friend and colleague, Wolf, who is also with us right now. And he said that maybe we can use the Chrome native client functionality for some distributed password hash cracking. And I said, that's great. And here you can see the performance we have achieved with the very first implementation without any performance improvements. So basically it's between the slowest JavaScript and the best native code John the Ripper performance, but it's distributed, so that's cool. I will just show you right now how it works. So here you can see that the native client module is already started from the extension I just installed, and the CPU is idle, so it's not working, the distributed password hash cracking. We are switching back to the attacker, and when we click on this button, it will instruct the Chrome browser to crack these SHA1 password hash for us. So we click it, and as you can see, the CPU is used. We have not implemented the multi-core functionality, but we might be. On this screen, you have to see the bottom left corner, the post infos part, where you can see that there is no data right now. I'm showing just that I'm not cheating, so we don't have any data right now. We are going back to the Chrome browser. It will take about 20 seconds. I have not cut this part just to demonstrate the real power of this. And in a couple of seconds, the CPU will drop down again to idle. And after that, we can check whether it's cracked or SHA1 or not. It has been finished, so we go back to the attacker side, click refresh, and there you go. That was the 5-character case-sensitive password which has been just cracked via a Chrome extension. I have also promised some Chrome OS demo for today, but unfortunately Google changed the way I can install extensions into Chrome, which means that my only option could be to upload my extension into the official store, which I really don't want to do right now. And I haven't found any way to install my extension into Chrome OS. So when I noticed this, I said, be cool, that's no problem. This sometimes happens. But what I'm going to show you right now is how one can spy on your webcam through Firefox. So first we go to the configuration directory of the Flash plugin. This is the real Flash, not mine. And if this directory is empty, this means that the configuration is empty. When you visit a website and there is some Flash content there, the Flash will create a new directory here, and in this directory there will be a binary file which is basically the configuration for that website. So as you can see, this is clear right now. And we also check from the victim browser that I'm not cheating, that if I visit my malicious website, then it will ask the user whether my application can access the webcam. Because the user is very secure and aware, he clicks on deny and closes this site. And I'm also deleting this configuration just to be sure that the user never ever visited our website and there is no cheating here. And I'm going back to the attacker side, click on demo, and click on this webcam button. What will happen in the background that it will basically create a new binary file in the Flash directory, which basically allows that the browser can access my webcam through the Flash plugin. And the Flash application I just created will take screenshots every 5 seconds, and it will upload these screenshots to my web server. So we click on webcam, and here you can see that the configuration file has just been created. And on this website, you might see this invisible iframe I've just injected right now. And this is the Flash application which runs in the background. And it is uploading the files to my web server. And there you can see we can spy on the user's webcam. We can also access the microphone and basically anything. I also have some suggestions. First, for antivirus developers, my message is that at least be reactive and download the publicly available malicious extensions, analyze them, and block them. Because today the browser is the new operating system. My message to browser developers, especially at Mozilla, is that first they should deny the extension install from third-party sites and enforce the official one. And I have also seen that basically in Firefox an extension can do anything they want. So they can change the Firefox configuration, they can change the update process of Firefox, they can change the block list process where the Firefox browser is checking for new malicious extensions, so we can block it. So it would be a good idea to rethink the architecture of Firefox extensions. And for the browser developers at Google, my message is that keep up on the good job, because what I have seen is that they have created Chrome in a more secure architecture, but this NP API, which stands for Netscape Plugin API, is still supported in Chrome, but not in Chrome OS. And basically with this, you can do similar things like I just showed in Firefox. My message to website developers is that basically there is no prevention against password stealing, but against cookie stealing, it might be a good idea to restrict the session IP to the user's IP by default. And for the users, my message is that please don't click on everything and beware of these malicious browser extensions. It might be a good idea to use a separated operating system for sensitive transactions like e-banking. And if your Facebook has been spammed with strange posts, then maybe it might be a good idea to install a new operating system and create a new profile there. And for the companies, my message is that if you control the application, what the users can install, then it might be a good idea to control the browsers as well. And in the browsers, you can even control the extensions. For example, in Chrome, you can set which extensions might the user install via Microsoft Group Policy. And I almost forgot that I have begun writing my Internet Explorer extension. So, thank you, and don't forget, browser extensions might be bad, okay?